All right, so this week we're talking about two-sample hypothesis testing. And we have the independent samples, and we also have the dependent samples, which we call the paired t test. And this week for the classwork, I'm going to break it up. We're going to have a classwork video just simply looking at independent samples, and then we're going to have a classwork video on paired t. And then when you get to the homework, it's going to be all mixed up, just like the test will be, but hopefully by going through these separately, you're able to pick out the independent samples versus the dependent samples on the homework and quiz and such. All right, so let's get going on two-sample hypothesis testing with independent samples. You're going to want open the two-sample in-class practice file, as well as a blank Minitab spreadsheet. All right, so let's just get started. A recent study focused on the number of times men and women who live alone buy takeout dinner in a month. Assume that the distributions are normal and the population standard deviations are equal. The information is summarized below. At the 5% significance level, is there a difference in the mean number of times men and women order takeout dinners in a month? All right, so on the quiz, it's going to be broken up kind of in an ABCD format. And step one is always going to be write your hypotheses. So let's start by writing the null and alternative. All right, so we have the mean for men and the mean for women, and it simply asks us if there is a difference. So we're going to have mu men equal to mu women versus an alternative that says mu men, and we're going to have to insert our symbol here for not equal. There we go. Not equal to mu women. All right, so there's our hypothesis test. It's a two-tailed test. All right, and now we can go over to Minitab to run our two-sample t. So we do have independent samples here. How is one way we know we have independent samples and that this is not going to be a paired t, other than the fact I've told you? We get this line here, all right, and this is talking to us about how to compare the population standard deviations or variances as equal or not equal. And so this is letting us know that the samples are in fact independent. And we're going to use this information when we conduct the test in Minitab. All right, so let's go under two sample, and we are going to go to t. All right, so again, that's two sample t. All right, let's talk a little bit about these three options in the dropdown, because in the homework you're going to use all three. So both samples are in one column. For this, all right, both samples are in one column. What would that look like? All right, that would look like, let's just go ahead and show you. That would look like something where you have number of times eating out. No, it's not going to let us do that. It's going to say times out and gender. And so, you know, maybe for some guy, he eats out 18 times. There's another guy that eats out 25 times. And so you would have information like this, where all of your numerical or quantitative data is in one column, and then you would have a qualitative column denoting here gender, okay? So that would be both samples are in one column. Here, both samples, being the times they eat out, are all in C1, okay? The other option is going to read each sample is in its own column. So that would be a situation where you would have a male column and you would have a female column, and then you would have all the male numbers and you would have all the female numbers. All right, so again, Let's go back to 2 sample T here. All right, both samples are in one column, would look like this first example in C1 and C2. Both samples are in C1, and then you have the qualifier in C2. All right, and so here C1 times out would be the sample, and gender would be the sample ID. Each sample is in its own column. All right, here you would choose male as sample 1 and female as sample 2, or vice versa, it doesn't matter. All right, but each sample is in its own column. Or you would choose summarized data like what we have here in the classwork. All right, so we need to put in our numbers, and I'm going to put men in as sample 1. All right, now in other words, I'm just putting it in the order that I read it. Okay, so there I've put in the sample size mean and standard deviations for both men and women. All right, we need to go under options. All right, and this difference is defined as sample 1 mean minus sample 2 mean. All right, so what Minitab is doing here is, instead of thinking of it as mu men equals mu women, what it's doing, and let's go back over here to the Word document for a minute, what Minitab is doing is mu men minus mu women equals 0 versus mu men, minus mu women, and let's copy our not equal to 0. All right, so this is what Minitab is thinking. All right, and so we want to choose our alternative hypothesis, and the question is, in the alternative, do we have not equal to 0, less than 0, greater than 0? And this is one of our easier ones because it is two-tailed, so we can choose not equal to 0. We can ignore the confidence level as we're not running a confidence interval. And then we need to know, do we assume equal variances? And we go back to the sentence here, the piece of the sentence that I underlined. The population standard deviations are equal. All right, so that means we do check this box and say okay. All right, we can scroll down, all right, to our test, and we see that Minitab is doing, remember, for our test, 1 was men and 2 was women. So it's doing mu men minus mu women equal to 0 versus not equal to 0, which is exactly what we have here. All right, and so then part B is going to say, well, what is your p-value? So you're going to say, all right, well, my p-value equals 0.0627. All right, so what is our decision? So since 0.0627 is greater than 0.05, we fail to reject the null, right? So when the p-value is greater than alpha, we fail to reject the null hypothesis. All right, and so then it's going to ask, what is your conclusion in the context of the problem? There is not enough evidence All right, so there is not enough evidence to conclude a difference in the mean number of times men and women order takeout dinners in a month. Okay, so if we had rejected the null here, then we would have concluded that yes, there is enough evidence. All right, but since we failed to reject the null, we conclude there is not enough evidence. All right, let's take a look at the second problem. A coffee manufacturer is interested in whether the mean daily consumption of regular coffee drinkers is less than that of decaf coffee drinkers. A random sample of 50 regular coffee drinkers showed a mean of 4.35 cups per day and a standard deviation of 1.20 cups per day. A sample of 40 decaffeinated coffee drinkers showed a mean of 5.84 cups per day and a standard deviation of 1.36 cups per day. Assume the population standard deviations are equal. All right, at the 1% significance level, is there a difference in the mean number of cups of coffee between regular and decaf coffee drinkers? All right, well, again, besides the fact we know that all of these are going to be two sample t problems, we know this is not a paired t because we are reading this sentence right here that tells us to assume the population standard deviations are equal. Okay? All right. So let's write our null and alternative hypothesis. And before we get deep into this problem, let me go ahead and warn you, this one's going to be a little bit confusing. Okay? This is why when you get to the two sample hypothesis testing, both independent and dependent samples, you're probably going to want to watch these videos more than once before you just dive headfirst into the homework, okay? This stuff does tend to be a little bit confusing until it clicks, but once it clicks, you got it, all right? So, all right, the question asks, all right, or the claim is that regular coffee drinkers drink less than decaf on average, all right? So that's kind of our claim here. Regular coffee drinkers drink less than that of decaf. All right, so we've got our null saying something and our alternative saying something. Since we read less than in the problem, and that's a strict inequality, that's going to be our alternative. So what we're reading is that mu regular drinks less than mu decaf. Right? That's what we're reading. And then, so the null would be mu regular is, let's insert our symbol here, greater than or equal to mu decaf. All right? All right, so we've got our null and alternative. Now we have to be super duper careful in Minitab, okay? And I'm going to step you through it slowly. All right, we're going to go to two sample t. We do have summarized data. All right, and I'm just going to put it in as I read it. So first I read the regular coffee drinkers, all right, and their mean and their standard deviation, and then I read the decaf Okay, so far so good, right? We've just typed in our information from our word problem, no big deal. But now we go under options, and we're going to have to choose the correct hypothesis. Okay? And these one-tailed problems are a little bit more difficult. All right, so we need to know, how does Minitab define the difference? Minitab defines the difference as sample 1 mean minus sample 2 mean. Well, sample 1 we put in as regular, sample 2 we put in as decaf. So I'm going to go down here in my Word document, and I'm going to say the difference is defined as regular minus decaf. Okay? Well, that is essentially what I can do here in my alternative. I have mu regular minus mu decaf. All right, so I can move mu decaf over to the left-hand side of the inequality, leaves me less than 0. Okay, so make sure that mathematically you see that these two inequalities are identical. All right, so my difference here matches the difference defined in Minitab, so I can choose less than 0. Okay, and we're going to do some more of these, so if it's not clicking yet, don't worry, just be patient and either listen to this one again or keep working through the problems. All right, and then lastly, we do want to check our box, assume equal variances, because it is stated to do so in the problem. All right, that is what I underlined here. All right, so we say okay. All right, and notice that our alternative hypothesis matches our alternative here, where 1 is regular and 2 is decaf. All right, so then I'm going to say, okay, well, what is the p-value? All right, the p-value is less than 0.0001. All right, so in Blackboard, Blackboard does not allow us to type in that less than symbol. So in Blackboard, if this were a quiz answer, you would simply just type in 0.0001, okay? All right, and so what is our decision? Since 0.0001 is less than 0.01, we reject the null hypothesis. All right, and if we reject the null, what do we conclude? There is, enough evidence to conclude that regular coffee drinkers drink less than decaf coffee drinkers on average. All right, so there is enough evidence to conclude that alternative. All right, let's take a look at number 3. All right, and here's another one that we're going to have to kind of slowly think our way through in Minitab. All right, a cell phone company offers 2 plans to its subscribers. At the time new subscribers sign up, they are asked to provide some demographic information. The mean yearly income for a sample of 40 subscribers to Plan A is $57,000 with a standard deviation of $9,200. For a sample of 30 subscribers to Plan B, the mean income is $61,000 with a standard deviation of $7,100. Assume the population standard deviations are unequal. At the 5% significance level, is it reasonable to conclude the mean income of those selecting Plan B is larger? All right, again, we know this is going to be a 2-sample T because we read the sentence right here. All right, so we're going to assume the population standard deviations are unequal. That tells us it is not paired T. All right, we want to write our null and our alternative. All right, and so is it reasonable to conclude the mean income of those selecting Plan B is larger? All right, so is mu B larger than mu A? Right, that's what we read in the question. So our null would be mu B, and we need to insert our symbol. Less than or equal to mu A. Okay, so far so good. All right, and we can go over to 2-sample T, summarize data, and we can put in our information as we read it in the problem. So we have 40 for Plan A, 57,000, 9,200, 30, 61,000, 7,100. Okay? Everybody good so far? All right, now we go under options. Okay, so we need to think through this. Minitab defines the difference as 1 minus 2. All right, well, what did we type in under 1? We typed in Plan A. So Minitab defines the difference as A minus B, all right? Because we put in A under 1 and B under 2. All right, so now we need to choose how that difference compares to 0. Well, notice here, if we just move A over, we have mu B minus mu A. All right, And so what we need to do here is we could go ahead and do that. So if I move mu A over, I have mu B minus mu A is greater than 0. All right? So notice this difference is opposite to what Minitab has defined the difference. So I cannot choose greater than 0 here. That is incorrect. Okay, that is incorrect. Minitab has defined the difference as A minus B. I need the relationship of A minus B compared to 0, not B minus A. So when I do mu A minus mu B, it flips the inequality. All right, so this is how Minitab is defining the difference. Mu A minus mu B less than 0. So I'm going to choose the less than 0 difference. Okay, I do not check the box equal variances because it says here, assume the population standard deviations are unequal. And I say, okay. All right, so notice what Minitab has here matches what I highlighted in yellow, and that is mu A minus mu B less than 0. All right, we get our p-value as 0.0220. All right, so what's our decision? Since 0.0220 is less than 0.05, we reject the null hypothesis. All right, what's it mean to reject the null hypothesis? There is enough evidence to conclude the mean income of those selecting Plan B is larger. All right. What if you had said there is enough evidence to conclude the mean income of those selecting Plan A is smaller? That is perfectly fine. Okay, same thing. All right, let's look at number 4. Businesses, particularly those in the food preparation industry, such as General Mills, Kellogg, and Betty Crocker, regularly use coupons as a brand allegiance builder to stimulate their retailing. There is uneasiness that the users of paper coupons are different from the users of e-coupons. One survey recorded the age of each person who redeemed a coupon along with the type, either electronic or paper. The sample of 35 e-coupon users had a mean age of 33.6 years with a standard deviation of 10.9, while a similar sample of 25 traditional paper coupon clippers had a mean age of 39.5 with a standard deviation of 4.8. Assume the population standard deviations are unequal. At the 0.01 significance level, test the hypothesis of no difference in the mean ages of the two groups of coupon clients. All right, so again, we know this is 2 sample T because we read a comparison statement here about how to compare the population standard deviations. All right, let's start with our null and our alternative. All right, so what do we read here? Test the hypothesis of no difference in the mean ages. All right, so we're going to have mu electronic not equal to mu paper, mu electronic equal to mu paper. All right, so just a 2 sample test here. All right, so we can go into 2 sample T. We have summarized data. We can put in sample 1, meaning the e-coupon, because that's what we read first, although it doesn't really matter. All right, and they had a mean of 33.6 and a standard deviation of 10.9. All right, the paper users, there were 25 of them with a mean age of 39.5 and a standard deviation of 4.8. We go under options. This is a 2-tailed test, so one of the easier problems, we can leave it on not equal to. All right, do we assume equal variances? No, we don't. It says assume they're unequal. So we leave this page as it is and say, okay. All right, notice our alternative matches what we have in our Word document, and we get a p-value of 0.0066. What's our decision? Since 0.0066 is less than 0.01, we reject the null hypothesis. All right, what does that mean? Now let me, oops, there is enough evidence to conclude a difference in the mean age of the two groups of coupon clients. Okay, and again, because it's a two-tailed test, we only know there's a difference. All right, we cannot say that e-coupon users are younger or paper users are older, even though that's the direction of the sample means. That's not what we tested. We simply tested not equal to. All right, so again, all you can do here is conclude that there is a difference. You don't know the direction of that difference. All right, last problem. The owner of Wild Wings wishes to compare sales per day of wing dozens at two locations, Greenville and Spartanburg. The mean number sold for 10 randomly selected days at the Greenville location was 83.55 wing dozens, and the standard deviation was 10.5 wing dozens. For a random sample of 12 days at the Spartanburg location, the mean number sold was 78.8 wing dozens, and the standard deviation was 14.25 wing dozens. Assume the population standard deviations are equal. At the 5% significance level, is there a difference in the mean number of wing dozens sold at the two locations? All right, so again, we know this is 2 sample T because we're given a comparison sentence on the standard deviations. All right, what is our null and alternative going to be? All right, we are simply asked if there is a difference. All right, so this is going to be mu Greenville not equal to mu Spartanburg, mu Greenville equal to mu Spartanburg. All right, so that tells us, all right, that this is a two-tailed test. All right, so we can go over here to Minitab to 2 sample T, summarize data. All right, and we read Greenville first. All right, there are 10 days, 83.55 and 10.5. All right, Spartanburg had 12 days, 78.8 and 14.25. We go under options. All right, it's two-tailed, so we leave the alternative hypothesis on the default. We ignore confidence level. And according to the sentence that I underlined on population standard deviations, we have to check this box of equal variances, and we say OK. All right, our p-value is 0.3928. Since 0.3928 is greater than 0.05, we fail to reject the null hypothesis. All right, since we fail to reject, what's our conclusion? There is not enough evidence All right, there is not enough evidence to conclude a difference in the mean number of wing dozens sold at the two locations. All right, so there's your classwork on independent samples. Now take a look at the classwork on paired T and see if you can't start doing some of the homework problems. As always, if you have questions on any of this or the homework or the quiz, don't hesitate to reach out.